In this video, I want to provide some of the mathematics behind propensity score matching, and in discussing the mathematics, we are actually going to explain why propensity score matching actually provides a relatively good estimator of the average causal effect. So the idea is that the Rubin causal model defines two levels of a potential outcome variable for an individual. So there is the value of the outcome variable had they chosen the treatment, and there is also for each individual, there is a value of the outcome variable had they not chosen the treatment. And the idea is that the individual causal effect of the treatment is the difference between y1i and y0i. So this is what we call the individual causal effect. In general, what we're more interested in is the average causal effect across our entire sample. So the idea is that what we're interested in is evaluating the expected value of delta I given that, let's say, di is equal to 1. So technically what we're actually doing here is we're evaluating the average causal effect for those that were treated. And we know using the above relationship that this is the same as the expected value of y1i minus y0i given that di is equal to 1. We know that we can rewrite this using the law of iterated expectations as the expectation of y1i minus y0i given that di is equal to 1 and also given that individual's propensity scores. And finally, what we're going to do is we're going to condition on the fact that di is equal to 1 to ensure equality with the line which actually came before that. And what we can do now is we can separate out this inner expectation into the terms that involve y1i and those that involve y0i. So if we do that, we get that we have the expectation of the expected value of y1i given that di is equal to 1 and also given the propensity score. And we take away from that the expected value of y0i given that we have di is equal to 1 and also given the propensity score. And then what we need to do is we need to remember to condition on the fact that di is equal to 1, and that ensures that we have equality with the line which came before that. So when we look at these two expressions, the first expression is something which is observed because these groups actually choose treatment and hence we actually observe y1i. So this is something which is observed and we can actually see this straight away from the data. On first glances, it looks like this expression here is counterfactual, and indeed it is a counterfactual because we're saying for these individuals who choose di is equal to 1, what would be their potential level of outcome variable if they hadn't actually chosen the treatment. But what the propensity score theorem tells us is that y1i and y0i are conditionally independent of di when we condition on the propensity score of a given individual. So what this tells us is that it doesn't actually matter the value of di which we actually use in this second expression. We could just change this to the value of di being equal to 0. And hence what we're doing is we are estimating this counterfactual by using something which is actually observed. This now is the value of the outcome variable which we actually observe for that individual, because now we're saying that di is equal to 0. So what we can do now is, because both of these two things are observed, is we can actually take away the 1s and the 0, because yi in the sort of notation of the Rubin causal model actually denotes the observed variable. So what is the interpretation of this sort of entire expression? Well, this first part of the expression is the average level of observed outcome for the group who choose treatment given a particular level of the propensity score. And the second expression is just the expected or the average level of the outcome variable for that group who don't choose treatment, who have a similar level of propensity score to that in the first group. So the idea is that here what we're doing is we are evaluating the average difference in mean for two groups which have the same level of propensity score, and the idea is that we are doing this across all potential scores in both the treated and the untreated case. So when we create the sample analog of this, what we tend to do is we tend to stratify our data. So what we do is we take the group who are treated and we stratify that across propensity scores. So we might create 4 different strata corresponding to slightly different propensity scores. And then what we do is we try to match that with groups, or subgroups rather, within our control group, those who weren't treated, who have similar levels of propensity scores. So the idea is that we compare the mean between the 2 first strata, the second 2, the third, and then the fourth. So the idea is when we actually form the sample equivalent of this expectation, what we actually do is we sum across all strata of the difference in mean given a sort of group propensity score, and we sort of take a weighted average across all of these different differences in mean, where the idea is that what we would actually do is we would weight by the number of individuals who were within each particular strata. And just to be clear, this should actually be a sort of W or omega S here, corresponding to the weight of that particular strata.